Welcome to MedTech Speed to Data, a KeyTech podcast. I'm your host, Andy Rogers, VP of Business Development at KeyTech. Each month, me and a KeyTecher are going to interview a MedTech leader and talk to them about the critical data-driven decisions they make in their programs. Hey everybody, Andy Rogers, host of MedTech Speed to Data, a KeyTech podcast. This is episode 21. We're legal now, I guess. On the podcast today, we have Senior Software Engineer, Partner at KeyTech, Lei Zong. Lei, thank you so much for coming on. Welcome to the show.
Thank you. Really happy to be here. I have to say, I heard a lot about this podcast and I feel very excited to be finally invited.
Yeah, I heard you are a podcaster. I know you listen to them in the car. And so, maybe you'll listen to yourself talk while you're driving. That's not awkward at all.
Hopefully we don't get there. But
Cool. Well, today we're going to be talking about something that I think is core to KeyTech and core to our customers. That's developing test beds to prove new technologies work. Prove that they're going to work on a bench, then prove they're going to work in products. The name of the podcast, Speed to Data. These test beds are the backbone of getting this data to prove new technologies. We've got a couple different projects going. Some are early stage. Some are, in the beta phase almost, where you're kind of now getting towards commercialization. But today's topic is considerations for the architecture for these test beds. And specifically, since you're leading the software group here at KeyTech, software considerations. So a lot of our customers have a new technology, either they've licensed or they've acquired from a startup company, and they really need to beat on that technology and prove it's going to work at scale. And these test beds are really what enable that. So these are really important platforms, these test beds that we develop at KeyTech. The entrepreneurs we work with, and Lei, I know you've interfaced with them a number of times over your career at KeyTech. It keeps them up at night. Will their technology work or not? Is their venture, sustainable? They need this data to prove to investors. Budgets are limited. Time is limited. They need that data. These test beds are important, and a lot of times, these startup companies, they'll have a PhD founder or scientist, but the problem is these test beds are multidisciplinary, right? And you need all these disciplines at work. So, I think that there's a lot of need out here for developing these test beds. So, Lei, when you look at it from a software developer's perspective and sort of as a systems engineer, what are the common needs for defining these test beds that you see with customers?
Thank you for that, Andy. As you said, I've been at KeyTech for a long time, it's about 15 years, and I've worked on a good number of all these test beds from the very beginning to all the way to, full scope development later on in their development cycle. And it's an area that we're really excited to see. It's a fun work for us, but over and over again, as you said, we have to look at things when the clients come to us. We have to look at things holistically from their perspective first, right? So as you said, what's keeping them up at night? What are the challenges they need us to solve for them at that stage of development? Getting the data out to prove that their tech work is critical. That's typically their first concern. But we also need to do this within a very reasonable, lean budget and a quick time frame. Just because a lot of these startup ventures, their funding scheme or the paradigm that they're following requires that quick turnaround, and they don't have the internal resource team to support this. So what we typically start discussion is, okay, so who are the users? What do you need this instrument to do? How long do you need the test fixture for? Typically at these startups, they will have PhD engineers or scientists who will be using these devices to do their side of the work. They're not necessarily engineers. They need a device that can be useful to them, but they are trying to minimize the amount of maintenance they need to do in order to do their day job per se. So what we're looking to provide, besides the technical expertise, is to make sure the test fixture first will provide the data they need, but also provide all that flexibility for them to test a range of different settings, configurations, etc. Early on, when you have questions whether this tech will work or not, you don't have a nailed down workflow or set of parameters, know exactly how things will work out. And that's exactly what they're trying to do with this test fixture. So they require a lot of flexibility to be able to tweak every part of this test fixture. So as part of that, they need ability to control modules or peripherals, say pumps or sensors, at a very fine granular level, right? They need to typically be able to interface to a PC of some sort. They want the data to be in the raw data format, as much data as they can grab, and they want to be able to parse that data in a multitude of ways after they get that data out. So some easy interface with a PC so they can, fine tune their algorithm, et cetera, is a lot of times is critical. And not everyone considers this, but it's certainly a good thing to consider early on, is while you're focusing on de-risking and just proving that your tech work. But it's also good to look forward a little bit to make sure, the energy and investment you're putting into this test fixture will serve you well in the long term, that when you if you're successful in proving your idea and you're building a commercial device, will this test fixture be a stepping stone to a larger architecture, or is this going to just be a dead end? So those are some of the high level needs that we typically see for test fixtures.
Yeah, no, that's great, Lei. I think the flexibility aspect of these test beds is paramount. I mean, they don't know what they don't know, right? And so you're building this airplane for the first time, right? Or the bones of the airplane, if you will, for the test bed. And so you need to be able to tweak parameters. So get the data and then revise as you go. So what are the different ways to go about architecting these test beds, in your experience?
Yeah, so a lot of times it's quick and dirty is the trick here, and that's what people are looking for. So a couple ways to go about it. Sometimes the clients may have a benchtop system in pieces, and they have done some proof of concept, and they could be using, off-the-shelf hardware like the National Instrument systems, hardware from National Instrument, as well as using LabVIEW to control those, or somebody put together a little Arduino or Raspberry Pi, and hooked up sensor if they feel more DIY about it. They have a benchtop system, and it might be just a few different things and literally string together on the benchtop, and they have done. And they, come to us and say, can you make this a little more sophisticated and robust and give us more flexibility, but use this as a starting point? And there are some pros and cons for this approach. And the off-the-shelf hardware, like the National Instrument hardware, definitely has a unique niche of what it serves, right? So it allows scientists or engineers who are not software engineers to quickly get up and running. There's a whole array of sensors or peripherals that you can use that get you up and running quickly, but they're also not cost effective if you need to produce a test fixture in a low end, right? So like if you scale up to 10 test fixtures for various people in your lab or even various locations of your lab, that it can quickly add up the cost of the fixture. Another major issue with that typically is reliability. If you have off-the-shelf hardware, you will have wires running from a lot of different places, hooking up sensors to your DAC, etc. If somebody bumps it, and we don't have a good diagram of how the connection goes, your system might just be broken. If you need to ship the system, chances are, those connections will break during transit. So it's not the most reliable setup, depending on where you are.
Just
So
real quick on that, though. I mean, you could go to market with a National Instruments based architecture, right? A commercial product, have it, but as you said, it's going to be expensive, right? So that's the off the shelf option. I think it's easy to see why someone would pursue that, if they're new to the space or just trying to get things up and running. But what are the other options?
yeah, so off-the-shelf hardware is not a way to scale up. So that's typically, if you want a stepping stone to enable you to scale up, you will consider something maybe a little more customized. So you could potentially have sensors that just need some conditioning before the signal gets into the software. And quickly, you might just get into the space where you just need to design a little PCB to do these conditioning. And depending on the range of the sensor you're looking for, they may only be available in certain formats, etc. So that's where we get into, okay, if you were going to lay out a custom PCB for signal conditioning or just accommodating a range of sensors, there are a lot of other advantages of that as well. It's much smaller, it's more reliable. You don't have hundreds of wires flying around. It's all compact on the PCB. And if you want to scale up, you can throw a microcontroller on that to do some real-time controlling or sensing of these peripherals. So you can build up, there's a whole range of things we can do for them at that point. But I think a lot of times people think about what's going to be on the test fixture, but not what's interfacing the test fixture, right? So that's a little bit of an afterthought, but it's a very critical piece of it is on the PC side, you will need a dedicated software platform to receive this data. A lot of times you want to have a concept of what is happening in the test fixture. So let's say that you have like a PCR test fixture to drive thermal control profiles. And a lot of times they clamp a consumable together and maybe there's liquid flowing inside. But because the way the mechanism work, you have no way of looking into it, right? So, but for whatever purposes you need it, you want to be visualize somehow of what's going on, where the fluid is. And it doesn't necessarily mean that you need to stick a camera physically into the test fixture. It's possible that we could render that visualization on the PC application just to tell you, okay, the fluid is here, the sensor is actuated, what's the temperature of those 10 or thermistors that's in the system. Just a way to give the user some more feedback of what's going on in the system while the software is capturing data. So that's where a lot of the software needs come in. Is one side is the firmware that's on the test fixture. The other side is this PC side of software to receive the data from the test fixture, provide the user interface, the visualization, and the control interface to work with the test fixture.
All right. So just to level set here. So there's the off-the-shelf option, and then you're describing this custom option where naturally you're spinning some version of a custom board and you've got firmware on that board. And now you need, a graphical user interface, basically software to interface to the human. So can you describe, how does KeyTech, in your experience, go about, implementing this custom architecture?
Sure. Yeah. I mean, it's a request that we've seen over and over again. So at KeyTech, we've been here doing this for, a couple decades now. We really have our reusable frameworks for both. On the hardware and firmware side, we have a lot of modules where the circuit design built up and corresponding firmware modules, drivers that we can quickly put together. I like to think that that's a reusable hardware software co-design package that we can throw at a lot of these test fixtures and build it up quickly. to provide the functionality. On the PC side, we have a platform that we've developed internally over the years called KeySharp that is made for this purpose to interface with some kind of hardware or some kind of test fixture that KeyTech develops. Custom message protocol that we designed and that allows the user to control things at very granular level, provides the graphic user interface and captures that data. And it provides this in such a range of capabilities, from very simple out of the box, very simple, command-based structure, to fairly elaborated, dedicated user interface. We can do anywhere within that range to meet the user needs.
The primary customer that I think needs these test beds in our experience are like assay scientists who are evaluating different parameters on the science side, on the assay side, and as you've described, temperature control and volumetric accuracy and volumetric control and all these variables. How would a customer, an assay scientist, use KeySharp? Can you just provide an example?
It's very graphic. It's a Windows-based platform, so most people are familiar with it. You install it and it pops up. It's very graphic. It's command-based. So there's this concept of a function, and in each function you can include a number of commands. And we customize this platform so that the command set available for a specific project is tuned, optimized for that project. So, you might want to control 6 motors, let's say, for your project, have an array of a dozen optical sensors, pressure sensor, syringe pump, etc. We can customize that quickly. We can create a driver or a dictionary per se that only controls those peripherals in the ranges that you desire. We can do that fairly quickly just because the way KeySharp is architected, it's meant to be very flexible in that sense. So we provide that dictionary of commands that the users can use, and they literally just select one, define what the parameters for each command they want, and build it up a little script. In KeySharp, we also have an area where we can do visualization for the user. So we can use a image of what the system looks like. If they're consumables, a lot of times you want to have an image of the consumable, understanding what where fluids are, what the regions of interest are on your test fixture. And we can have interactive feedback of, when something interesting is happening, KeySharp will tell you, hey, this event has occurred, this status has changed. So you can look at, okay, the motor has moved to a certain location, the fluid has arrived at triggered certain sensors, it has reached some temperature, or detection has occurred, and this is the raw value of my optical sensor from the detection, etc. And it also will collect all the data coming back from the firmware. We have ways to control the reporting frequency and content from the firmware, from the text fixture. You can collect hundreds of data points multiple times a second. It streams all that in a format user can define into a CSV file, so you can use that easily for post-processing.
So the customer then has all that data, and a question for you, just taking it one step further. So let's say you set all these parameters, you run your assay on a test bench, whether it's developed by KeyTech or whoever, and you're at the end of that assay. How are these scientists actually evaluating whether the assay is working or not? So in my mind, KeySharp is setting you up to do a run, and then maybe you're looking at a certain fluorescence level, or some positive on various electrical signals, I guess. But how are they proving that the assay is working or not with these test beds?
Yeah, for essay, typically they have gold standard they can compare to, right? So that might just be a manual workflow that you're using off the shelf PCRs to do that PCR cycle. You're doing some kind of manual pipetting or putting into a spectrometer per se, or some kind of microscope to evaluate it. And that was like your original workflow that's very manual. And what you're trying to bring the value you're trying to deliver in this product concept is that to automate all of that in a very realistic way. So typically they will have some gold standard to compare to.
Cool. So you can program the assay and all the parameters as you wish. You can script and run as many tests as you want, and iterate. And KeyTech supports that. I guess the customers are running that testing.
Yeah, right. So I mean, we definitely support our customers through this process. They may request additional features of KeySharp. KeySharp is built to be very flexible, right? So there are a lot of features coming out of the box, but it might not meet 100% of your needs. So another advantage of KeySharp is we can add things to KeySharp fairly quickly and at a reasonable cost. So if KeySharp does not meet your need as is, there are always ways that we can extend beyond the existing set of features and add more customized features for a specific customer. So, we certainly support the use of KeySharp. We will train the user how to use it. And if they have additional requests to add features, and that's certainly something that we're very familiar and support our customers on.
You mentioned, forward-looking, forward-thinking as you're at the beginning trying to develop a test bed. Can you just describe how KeySharp is sort of architected such that the bones are in place for forward-looking applications, commercial applications?
Sure. So this may be a little different than test fixture that we're talking about. For commercial applications, for commercial applications, when we build an integrated prototype for a larger device, we still use KeySharp to control those for internal testing, right? And for chemistry testing at the client site, etc. But so people are very familiar with that interface that KeySharp provides. But on the other side, once we implement custom PCBs and custom firmware in the instrument in an integrated prototype, and that's a few steps down from just a test fixture, you would typically have a lot of custom PCBs and custom firmware in a device at that point. We want to make sure that we're building pedigree along the way on the electronic platform as well as the firmware platform. We don't want to change that unless we have to. So what KeySharp provides is that it provides the user the interface to do assay verification or assay research study, but it will also provides that foundation of communication with the firmware so you can build your final software product on top of it. So when you think about launching the product and your end user, they may not need all the knobs and tweaks that you use during development, right? So a lot of these devices needs to be sampled to answer in as much automation as possible. One press, you're a couple steps and you walk away. So they don't really want any more configurations. They want to be able to just set something up and walk away. So the end software, the end user facing software typically is fairly straightforward and very much locked down. So what KeySharp can provide you is we can use certain portions of KeySharp as the communication layer with firmware. So from a firmware perspective, nothing has changed. I'm just talking to something on the PC side. And then we just put on over a much prettier UI layer over the core modules of KeySharp and send that out as the final software. So if you think about, it's still you or it's still me. Some days when we need to go in the lab, we need to put on our work clothes that, with all the tools, and then it allows us to do things. But sometimes when we go out to see clients, we're going to have to dress up a little nicely. We put on a pretty jacket. You can change that skin, that outer layer, that external user-facing layer, but the core functionality is still the same. And what's more importantly is we're not disturbing the firmware side, and we're continually building pedigree on that side of things. So we just have a higher confidence that the device will work more reliably once this hits the market.
So yeah, Lei, thanks so much for describing the options that are at play here for developing these test beds, architecting them from a software and electronics perspective, right? So you've got off-the-shelf methods, Arduino, LabVIEW, National Instruments type approaches, which work, and there's a place for those, or slightly more custom options, maybe hybrid is a better way to describe it, using the KeyTech KeySharp software as a viable option for evaluating these new technologies, getting that early data, and then potentially, translating that test bed architecture to your commercial application. So, Lei, thank you so much.
Really happy to be here.
Thanks for tuning in to MedTech Speed to Data, a KeyTech podcast. Join us each month for more ways to get the right data faster to inform critical decisions. Find additional resources on our website, keytechinc.com. If you like this episode, don't forget to subscribe, and please leave a review on iTunes whenever you listen. Thanks.